Welcome everyone to Codeworms. So today's video is called the diameter of a binary tree. Now what is exactly a diameter of the binary tree? It is, in very simple terms, the longest path between any two nodes in the tree. This may or may not pass through the root. Now, because of this, we have two conditions here. Essentially, one where we consider that the longest path will be passing through the root. Now, if we look at this root, so the basic intuitive method to solve this is we find out the height of the left subtree, we find out the height of the right subtree, and then we add the two, right? Now, let us take into account if by chance, suppose that the longest path does not cross the root. For example, we have this tree now. If we look at this 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7, 8. This is obviously the longer path, right? So in such a case, we cannot consider the left height, the right height, and add it. It is going to give us a wrong answer. But suppose we do not consider this as the root and we consider this as the root, then we can exactly follow what we had done previously, right? We can figure out the height of the left subtree, we can figure out the height of the right subtree, and then we can add them. Now, this is the concept. We need to figure out which root exactly we want and then figure out the height of the left, height of the right, and add it. Very easy. Now, what is basically happening here? So suppose this is my root node here. Then we find out the diameter of this node. We find out the diameter of this node. And then we check for the maximum one. Whichever one it gives me my maximum diameter, then that will be basically my diameter of the tree. Correct? So maximum of right diameter and left diameter. But now the question comes, when do we understand whether it's a root node? Like whether it is passing through the root or it's not passing through the root. For that, basically, we will consider it to be both, right? So we will take the maximum of this portion and this portion. Now, I hope this is very clear to you. What we're going to do now is we're going to look into the time complexity of this situation. So what we have to understand is if we are executing this or if we are returning this command, the problem with this is it's going to find out the left height recursively, the right height recursively, the right diameter and the left diameter both recursively. Now, what happens in this is if we're figuring out each and every piece of it recursively and individually, the time complexity increases a lot. So what are we doing to improve this time complexity? It is actually very easy. We are visiting each and every node, right, to get its left height and right height. We will have a different function which will give me its height. So while we're doing that, why do we not calculate the diameter at that particular moment? So suppose if I want to find out the height of this node, why do I not find out the diameter of this node at that very particular point? What happens is my code, the complexity of my code becomes easier and simpler and better. So let us take a variable, say answer. And what we do is we save the maximum of the answer that we already have with the left height, the right height, Okay, so what are we doing here is, suppose we are taking this node, right? So what I am searching for is, my answer here is basically, if I look at it, it's 2, right? So my left height here is 0, my right height here is 0, and it's 2. So this is my diameter, and my answer for this is basically 1. So what is it going to store at the end? It's going to store my diameter. Again, when I check for this one, my left height is 1 and my right height is 2, right? So that is a total of 3. And my answer here was 2 because that is the diameter. That is the highest. But this time, basically the diameter of this node is higher than the diameter of this node. Then we take this entire node. Now again, when we calculate the right height and we'll calculate the left height and we'll add it and we'll compare it to our answer, the final thing will give me the diameter of my node, correct? So basically what we're doing is we're finding out the height as well as the diameter for each and every node, and we're figuring out the maximum of the height and the diameter, and we're returning that, right? So this is the explanation. Now let us look into the code. Right, now that we have gone through our explanation, let us go through our code. What is the first thing that we do? The first thing is we obviously make the height function. And we pass the node in this. Now, because our height function will be a recursive function, we need to keep a condition where this recursive function needs to stop. So if my node is equal to null, then I will return a -1. Else, what do? I find out my left subtree. Or I then find out my right subtree. What do we do now? We have to keep a variable called answer. And what do we save there? We save the maximum diameter of the previous node and this node, whichever one is the maximum one. But this function is of the height, right? So what do we have to return? We have to return the height of this tree. So what is the height of this tree? The height is the height of the maximum height between its left subtree, its right subtree, and then because this is a new node, we add 1 to it, right? This is our height function. Now what have we forgotten? We have used the function max, but we have not initialized it. We have not made a function called max. And we return whichever one is the highest, right? Great. Now, what do we have that we've not initialized? Yes, we have answer, which we've not initialized. Now, because answer is something where we have to keep calling it, and we have to check it with the previous answer and check it with the new answer and then check its maximum. This needs to be a global variable, correct? Now, if my root is null, or if my root dot left is equal to null, and my root dot right is equal to null. What does this case mean? The first case means that my root is null. That is, I have no elements in the tree. My second case means I have just one element in the tree. What do? I return a 0. Otherwise, what will happen is I will call my height function and pass my root in it. Now, once this is done, it will return answer. It will give me my final answer. And since answer is global variable, we just have to return answer. And that is the diameter of our binary tree. Let us check if we've made any mistakes. No, we haven't. Let us submit this and check if we've made mistakes. Nope. Now, there, it has passed all my test cases. So that is the end of the diameter of a binary tree. If you have any questions regarding this program, or if you want us to do other programs for you which you cannot solve, please do write it in the comment. Tell us how you like the video. Tell us what more you want us to do. Like the video, subscribe to the video, comment. Thank you so much and happy learning.